basically you're saying that the phishing example, if we all got together and made a rule of exogenous, but I'm not clear on what an exogenous is.
An exogenous situation might be where some outsider comes and makes a rule for you. Yeah, that would be an obvious one. That's basically it. So if endogenous just means that the people who are acting are making decisions that are changing, that are affecting what's going on. So, for example, you go to a store and you want to buy a quart of milk, and it says $1.45 or whatever. That's an exogenous price. And then you go to the store in Egypt and you say, I want to buy some dates. He's like, it's $2 a kilo. You're like, how about $1.50? The price is now endogenous. You're bargaining. Okay? So that's kind of one way to keep it straight. So I'll throw out the word very often, but it's useful to keep track of that. Okay, is the tape rolling okay?
Yep.
Great. Swine flu. If you get swine flu, don't come to class. I already had it this summer, so it was very exciting. I recommend that you don't get it, but if you do get it, you're supposed to not come to class. I'm supposed to give you all kinds of excuses. You don't need paperwork, and so keep that in mind. It's very likely that everybody's probably going to get it by the winter time, so look forward to a very high fever. But you should notify me, especially if it's related to a deadline. If you don't come to class, then hopefully at some point we'll get our act together and get all the video and audio up there so you can catch up if you feel like it. So somebody asked me about the blog entry. It's due on October 1. Let me give you some, I want, for the sake of expectations, and so you guys know what I'm looking for and you can start thinking towards it, I want to outline a little bit about the blog entry. Who has actually written a blog entry ever? Okay, about a third or 40, 50%. So you might have a clue about what's going on. Those of you who have written a blog entry, it's basically your opinion about something. And what I want you to do is take any issue and analyze it. Okay, and any issue, you don't have to solve hunger. Okay, start with something small. Why do the AC transit thing is an example, but that's obviously that can grow very large very quickly. So you want to say, why is it that some cars have lots of bumper stickers on the back of them and some don't, or anything like that? Whatever is interesting to you, and so it's your opinion, but I want it backed up with analysis. It's going to be economic analysis. And as I mentioned before, I'm not going to grade your blog entry, so it's almost when I said it's intrinsic motivation. You want to do a good job because this is you being an economist, okay? Now, they said, how long is it? Well, it's like, I think somewhere between 100 and 500 words, or as they say, as long as it takes, okay? So I have on the post this morning a big opinion about the aspect of fear in our culture, and I counted the word count as 600 words. It took me about a half an hour to write that yesterday. So also, it should probably be your first or second draft. Don't sit there and get all excited about having perfection. 600 words is really long. 100 words can be fine. You could write a haiku. I said, Kevin was like, go ahead and write a haiku. You can do a video version if you feel like it. What I want you to do on October 1st, this is all time-stamped, I want you to email it to me. Okay? I want to email it to me plain text on an email, okay? Not Microsoft Word, which is like a disaster in terms of HTML. So just send me the text, and then say blah, 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 and then, if you have a link to a website, just put that in square brackets so that I can insert the links for your stuff. And if you have a picture or an image or something like that, you can either send me an HTML link, HTTP link, because the image is on the internet somewhere, or you can send me the image as an attachment, all right? And let's call this, so October 1, midnight, let's call it that, right? So if it's this time, Pacific Coast time, okay, so don't do Hawaiian time. And and it'll be timestamped. So basically, if it's in my inbox, you get credit. If it's not, you don't, all right? And then I'm going to post those in a reasonably random order as long as it takes to get them all out. If there's 90 students and I put up 2 or 3 of these a day, it's going to take 30 to 45 days to get them all out on the internet. So, and I'm putting it in random order because in order for you and your parents to check my blog every day to find out if the post went up. Oh no, it's somebody else. All right?
You mean 12 a.m. October 2nd? Or?
I mean 0001 equals 0 points. Okay? You can send it to me today if you want to. There's no reason to delay. You don't have to wait for the events of September 30th in order to write a blog post. But I want you to get it in. Does that make sense? Okay. October 1st. Not the 2nd.
So the topic doesn't have to be related to like environment.
It has to be related to environment or resources in some way. Okay? It could be, I mean, I'm talking about political economy a lot, so you can bring, if you want to bring political economy, if you start going off into the drug war, it's kind of a little bit more vague. If you talk about why I like shoes, I don't want that, okay? So try and keep it somehow tenuously connected to the material in this class, okay? And it's really, and if it's something, the easiest thing to do is write about what you know, okay? If you're a baseball player, write about baseball. If you like knitting, do that. If you hate cats, go do I hate cats, okay? So just do something that you know. Don't sit there and go read the encyclopedia to try and figure something out. And don't cut and paste a Wikipedia or something ridiculous because it'll just be boring. Good enough? Any other questions on that? Not just yet? Okay, that's just a little reminder. Now let's go back over statics and dynamics a second because I just wanted to re-emphasize where we left off last session. So the statics versus dynamics, as I mentioned, you just go from statics is, and let's just do it this way. This is easy and hard. And I mean hard to explain, to diagnose, to analyze, because when you, we'll do some more game theory later on, but when you think about, I mean, just consider a chess game, okay? A chess game is pretty much a very good example of a dynamic. That's why game theory is named game theory. It's how people play games. And you're playing an opponent, and the opponent knows what you're doing, and then you know what they're doing. So you're going back and forth trying to outsmart each other. So dynamics is very hard to diagram. It's very hard to do mathematics of dynamics. I do experimental economics, which it's kind of experimental economics, which I'll be doing later this afternoon. It's the experiment is an auction, right? How do you determine what people are doing in an auction? And the mathematics of it to try and figure out what your strategy is, and then your opponent's strategy, and how you respond to that. But then there's 7 other opponents. That just blows up out of control immediately. All right, it's like imagine an 8-way chess game. It's just going to be impossible. So the math falls apart, and what that means is that it's hard to really get a very concrete idea of what's going on. That doesn't mean that you don't have a feel for what's going on. Okay, you want what I said before about the difference between theory and reality. We know that things are going to move in a general direction. And when you have a game of chess, you know that your opponent is trying to beat you. You know that's true. How they're going to beat you is the hard part. That's the complicated part. And most chess players don't try and predict the game in advance. They just try and stay as in touch with as many moves as they can, so that they can make that or they can beat their opponent. When you get to statics, it's much simpler. It's like a playground swing. I get on the swing, I swing. You know, you don't have to deal with what the swing is. The swing is an exogenous thing, right? The swing is just sitting there. You get on it, you swing. It's very simple to understand. And in fact, a lot of economists have made the mistake of using physics to try and explain economics. And physics is, you know, that can be quite easy because those particles in physics, they don't get upset if you touch them the wrong way, right? But humans are much more interactive. And the worst thing is, and this is what back to the endogenous thing, when you change the law and then you expect people to not change their behavior, you've just made a huge mistake, right? So not just because of the law, but you know, say that you raise the price of something. Here's a good example of statics versus dynamics. So let's say that the demand for gas is equal to whatever, 1 billion gallons. And the tax is 10 cents a gallon. So you're going to get $100 million of taxes, right? And then you double the tax to 20 cents a gallon. Are you going to get $200 million of tax revenue? No. Okay. First of all, we know you're not going to do it because just the pure law of demand, right? Because you can expect that to happen. And unfortunately, a lot of politicians don't even get that far, right? But then you might have this situation where 20 cents, this might be so small that no one pays attention. But then it's like there's a headline in the newspaper, people are like, oh, gas, why am I using gas? And so they really change their behavior in a dramatic way. And if you treat the gasoline tax like a static environment instead of a dynamic environment, you're going to make a mistake. So that's why you want to just keep it in mind. You have to keep in mind that people are going to respond in different ways, and that this very simple prescription that you're going to go from 100 million to 200 million is going to be wrong. Yeah?
Is there one in which the rules don't change for between statics and dynamics?
What do you mean one?
Like, I mean, if you're saying that there's like a general, I guess I'm a little confused about rules, like the standards of how this plays out. Is there one between them that the rules don't change?
Don't change.
I don't really know how to.
I'm not getting it.
Oh yeah, I don't really.
Give me
really
have an example, or should I come back to that?
Okay, yeah.
Okay? Hit me when you think of what I'm supposed to, or whatever I'm supposed to respond. I don't quite know how to respond to it. I think, there's a continuum between these two, right? You have very static environments, we're all dead, right? And you have dynamic environments, we're all running around playing whatever, soccer, right? So in between you've got, and that's actually, sports is not a bad idea. In between you've got set things where you might have football, American football, where everybody sets up on the scrimmage line and they do the same thing over and over again, right? Whereas international football, they all run around and no one knows what's going on, right? So, or they think they do. So there is a continuum between this extremes of dynamics and extremes of statics. And then to keep back with the easy and the hard thing, we've got partial equilibrium versus, I'm going to put the double-headed arrow here just to show that that's that continuous difference. See how bad my handwriting is? God, it's really getting worse. Okay, partial equilibrium versus general equilibrium. And partial equilibrium might be where you have just a little demand curve, and this is, we get back to our favorite pork, and you've got the price, you've got the quantity, and you say, oh, what happens when let's just do this, it's the supply, we put a tax on. If I do this and the price goes up, I'm going to have less quantity. That's just a basic partial equilibrium analysis. I'm looking at that and I'm saying that's going to happen. But then you get into general equilibrium and you say, well, wait, if that price is going to go up, how is that going to affect the supply and the demand for chicken, right? And so if the price of pork goes up, the demand for chicken should go what? Up, right? Because they're considered substitutes. They're considered, or the best example might be Coca-Cola and Pepsi. Like, what is the difference, okay? So if the price of Coke goes up, then the demand for Pepsi will go up, right? Because the people will be shifting from one to another. What's that called? What's the jargon for that kind of elasticity?
Cross-pricing.
Cross-price elasticity, exactly. Cross-price between products that are substitutes for each other, or even complements for each other. So this is partial equilibrium. As you start adding those impacts to the other goods in the market, you know, pork might be related to barbecue sauce, and because that's barbecue sauce is a substitute or a complement for pork. Complement, right? Because pork and barbecue sauce go together, and chicken is a substitute, right? So as you start taking all these things into account, eventually you end up going to, you know, sales of barbecues and the employment of teenagers during at Lowe's or at Home Depot, and then the demand for hot rod cars because of teenagers' wages. It gets like boom, it blows out of control, right? Out of comprehension, but it's all happening because out there in the world, we have all these dynamics going on all the time. So you have to keep in mind that there's, and besides the idea that equilibrium doesn't really happen, okay, you have to keep in mind that all these things are moving around, and we use this partial equilibrium analysis just as a form of simplification to talk about some basic ideas, some basic economics. Statics and dynamics. Now, the third kind of example of easy versus hard is going to be in the marketplace, if we have a perfectly competitive market, what does that mean in terms of the consumers and producers in the market? Are they in the market, or do they see that? Is the price in the market endogenous or exogenous? Perfectly competitive. I'm linking all this jargon together in one sentence now. Perfectly competitive market. What do we assume happens when you go into the marketplace as a participant?
That only a trade can take place if they're both happy?
Not exactly. That's always true. Do you affect prices in a perfectly competitive market? When you go down and I'm buying an iPhone and my demand is significant, so give me a deal, right? Does AT&T or Apple care about me? No. So what is that called when you don't affect prices? Price taker, right? What's the opposite of a price taker? Price maker, or whatever. You're affecting prices. So this is exogenous. I'm just going to kind of draw a thing. And this is endogenous. You're a price maker. What's that? Who's a price maker? What's a classical example of a price maker? Monopoly, right? Now, let's be much more complicated. How do you get much more complicated than a monopoly? Perfectly competitive, essentially, in economics means almost an infinite number of firms that are all entering the market and competing. And it's actually quite hard to find a really good example of that, but it's kind of like a wheat farmer. That's the idea. You can't affect the market, right? But and a monopoly might be the opposite. It might be Cargill, and Cargill controls. Actually, so is Cargill a monopoly in terms of buying agricultural output? Has anybody heard of Cargill?
Is ADM?
So ADM is a competitor for Cargill. So Cargill's not a monopoly, right? The way that GM and Ford are not monopolies, right? They are what? That's an oligopoly. In fact, most of the world is oligopoly, right? The perfect competition price taker scenario is, again, a simplification, right? The monopoly scenario is another simplification. We're going to get into this later on, but in the middle is basically everything, right? You have this range from over here to over here, and this might be a monopoly, and there might be very, very few examples of monopoly, and there's very, very few examples of perfect competition. Almost all of the world is about oligopoly, okay? And maybe when you walk into a supermarket, you might say, you know, wow, it's my demand for tomatoes is not going to affect the price of tomatoes. So you might be, as a consumer, a price taker. But then you might go to the farmer's market and do what? With the farmer who's selling the tomatoes. Huh? Bargain, right? So you're going to start affecting the price. You actually have market power, right? You're not necessarily, what's it called when you're the only purchaser, not the only seller? Monopsonist, right? So if you're not the monopsonist in the tomato market, but you might be the monopsonist in the market to buy the car from your little brother, right? It's like, well, you know, I don't have any money. I'll give you $500. Your little brother's like, ah, but you know that can happen, except that your brother has friends. So then you're going to be in an oligopoly, and you're going to be competing with other people, and then we get this kind of imperfect competition called what I said last time, Craigslist, right? You're trying to figure out who to buy and sell from, and the transactions costs in a non-perfectly competitive market are greater than zero, right? So that's where the oligopoly comes in here. Everybody has some power, right? And the friction between them, in a sense, is a transaction cost. That's advertising, that's persuasion, that's bargaining, all kinds of things. Okay, so that's a little bit of more about statics and dynamics. Any questions about that? We'll get back to that endlessly during this semester. Yeah?
In this example, we have the perfect competition as static, and the monopoly as...
Not exactly as static or dynamic. I'm just saying easy versus hard.
Oh, okay.
Okay, so this perfect price taking is easier to understand, right? And static is easier to understand, but price taking isn't necessarily static.
So this doesn't necessarily fall under the statics versus dynamics.
No, I'm just saying it's like it's just these are different examples of the easy versus hard. That's the continuum I'm trying to draw.
Oh.
That's a good question. Yes.
Aren't there a lot of monopolies on a local scale? Like
Yes.
in a lot of towns, there's only one energy company or one cable company.
Right. So actually, yeah, so that comes under the category, it's defined often as a natural monopoly for cable or for water or for electricity. A natural monopoly essentially meaning that the cost of setting up a competitor is so high because you have to lay in a bunch of other cables, okay? And so those tend to be regulated. So you have regulated cable companies, regulated water companies, regulated electricity companies. In a sense, the government provides the roads. You don't have two sets of roads running next to each other where you can switch back and forth, except where? Anybody from Southern California?
Toll roads.
Toll roads, right? Those are often set up as a competition against the public road, and in a strange way, because ironically, the government that gives the right for the toll road, do they want to have a lot of revenue or a little revenue? A lot of revenue. So they want to keep the price of the toll road high, and that moves more people into the free road, which means that there's no revenue. So they go back and forth. They're trying to, set these prices, and often they set those prices what? Dynamically, right? Rush hour pricing, congestion pricing. If there's a congestion, they're going to raise the price because more people want to get on the road. If there's no congestion, then they lower the price because they want people to stay on the road, right? So that's how these prices will fluctuate up and down. So these things are going on all around us. Okay. Other questions on this stuff? We'll be back to statics and dynamics. Okay, so let's do math. Woo! I'm going to start off with a little math example, then I'm going to get through some more stuff that I didn't get to last time, and then I'm going to go to a big math example, because next week in section, Diane and Faye, right, we're doing constrained optimization and stuff. Where did Faye go? There you go. Okay, yes? Your favorite, right? Okay. Lots of math and discussion. And there'll be a homework, and the homework is going to have the math, so that's why you guys need to start putting on your math caps. So why do we use math in economics? We use it often just because it's shorthand. It helps us understand things. It just makes it it just makes it clearer. Okay. So when we say that utility from the good x is equal to the natural log of x, you're like, oh, natural log. What the hell is a natural log, right? I don't even know what an unnatural log is. But why do we use this? What's this shape look like? Anybody help me out on that? The general shape. It's like people making the shapes, right? It's like it goes like this, right? This is 1, right? But basically it's increasing at a decreasing rate, okay? And what is that? What is increasing at a decreasing rate? Decreasing marginal what? Did you say it? No, well not, in this case, this is this. What's this called? Utility, right? Decreasing marginal utility. So this is actually u of x. What does u prime of x look like? If I draw it right underneath here, it's going to be like this. Okay? This is marginal utility. My marginal utility is falling as I consume more and more x. My first ice cream cone, my second ice cream cone, my third ice cream cone. This concept will come up endlessly, right, in economics and in life, and it's really useful to take into account.
What's the marginal line again? Positive? It's increasing.
This is all positive.
Oh.
Yeah, I just drew another axis here.
Okay.
Right? Okay. So, although this is completely wrong because, or no, this is falling. It's falling from because it's coming down, right? Because this is actually it goes to negative infinity or whatever. But the reason that we're using this math here is just as a way of describing utility, right? We're just trying to use the same concept. Is this any different from that? Economically? It isn't, right? It's the exact same thing. Root x. All right, I'll do root x. Whoa, looks pretty similar, okay? 2 times root x, the same thing. 14 times root x, it's the same thing. We're just trying to describe this economic phenomenon. Clearly the math is different, right? But don't get attached to the math, get attached to the economics. Okay? We don't have, is this a utility function? Or is this a good utility function?
Depends how much you like whatever you're consuming.
You like it more and more and more and more and more, right? I can't even think of something like that. Right? I mean, almost everybody satiate. In fact, this is actually, let me get to satiation. There's a lot of assumptions that we put into economics, and some of them are pretty stupid. So one of them is called non-satiation. What does that mean?
You never get full.
You never
Never get full.
get full of ice cream, right? I mean, after a while, you will throw up from ice cream, right? So if we look at the utility of ice cream, it's going to be like this. That's when when you were a little kid and someone said, have all you can eat, and you ate like 2 gallons of ice cream and then you threw up. That's negative utility, right? I ate too much, I threw up. So it's still decreasing, but now it's actually negative, right? This is actually satiation. Why does satiation matter? Because there is a limit to how much we can consume, and that actually ends up being a problem with the math, because then you run into a wall with your mathematical functions. You're assuming people will consume infinite amount, never stopping, but they'll run out. So that's or you run out of space. Like, how many shoes can you have? Well, how big is your closet? Imelda Marcos even ran out after she had what, 2,000 pairs or 12,000 pairs? I don't even remember. It was a lot. But she didn't have them all, right? She ran out after all. She was the wife of a dictator. She still ran out. She didn't want that many shoes. She couldn't. She stopped. She satiated. So the math is useful in some of the mathematical assumptions, but some of the mathematical assumptions can be autistic, right? There's actually this is one of my favorite. There's a movement for post-autistic economics. And with all due respect to people who are or know autistic people, post-autistic means don't be retarded when you're doing economics. Okay? It's like the economics has to match the real world. Post-autistic means don't do this non-satiation assumption and then go out in the world and pretend that you know what you're talking about, because there is some satiation at some point. This post-autistic, if you're a skeptic like I am, you love these guys. It started with the French, believe it or not. So let's go to, is that the start with the math stuff? Right. Okay, we'll go back to that in a minute. Now, back to supply and demand. Okay, so I got some. So here's some data that I was doing with water, and it showed the demand, the price of water, and the per capita gallons per capita per day demand for water. Okay, and the price, and this is real data from the Bay Area, and the price was let's see, let's just call it $3, and the gallons per capita per day was 50, and the price was $5, and the gallons per capita per day was 100, and the price was $8, and the gallons per capita per day was 200. So I've got Q and P, I've got 3, 5, and 8, and I've got at 3, I've got 50, and at 5, I've got 100, and at 8, I've got 200. Is that a demand curve or a supply curve? This is actually, these are different towns here. Hillsborough, anybody heard of Hillsborough? Hillsborough is a very wealthy place. Redwood City, not so wealthy. In between, whatever, San Mateo. Is that a supply or a demand curve there? Supply curve. But this is the demand for water in Redwood City at that price. What's going on here? Is it? I mean, it's not really a supply curve, right? It's like if you connect the dots, it's like, wow, that should be a supply curve.
So each of those is for each of the different cities.
Yes.
So then the difference is income, ability to afford it.
Okay, and the difference is income, so what does that mean in terms of what's going on here? Somebody else. Is there a demand curve, or is it just like no demand, whatever? What's going on? You can speak up, it's okay. Don't hesitate, it's fine. How many weeks of Econ 1 did you take? What's going on? Write it on your piece of paper if you can't say it. Somebody say something.
Is it like differential prices where they're charging different amounts of water depending on how wealthy the place is?
How well?
How wealthy the place is?
In a sense, yes, the price is changing depending on how wealthy the place is. So, does that mean there's more than one supply curve? There's multiple supply curves?
Technically, if it's 3 different cities, isn't it 3 different demand curves?
Yeah. It's just 3 different demand curves. Alright? So, this is the demand from a wealthy city. Someone said earlier, it's like, well, this is income shifting. Absolutely, right? It's lifestyle water, in a way. If you live in Hillsborough, you've got a big lawn, you've got a pool. If you live in Redwood City, you live in an apartment on a walk-up. Okay? So, the point is that when you see a bunch of dots, you might not be sure if you're seeing demand or supply. Okay? If the price of water in Redwood City falls from 3 to 2, or sorry, let me do it a different way. If San Mateo goes from 5 to 4, is San Mateo going to use less water because it's Redwood City, like Redwood City, or is it going to use more water?
It's the same thing.
Same amount? Maybe. Is that what you asked?
Yeah, it's the same amount of water.
The law of what? Demand. I'm a conductor without an orchestra, right? The law of demand says that the redwoods, you just lower the price. This is why the graphics are kind of helpful sometimes, right? You lower the price and the quantity goes up, right? So you're still you'll be moving along the demand curve, right? This is an important. This is getting a messy diagram, but you're moving along the demand curve when you lower the price. What's the difference between, why are these demand curves, let's move it a different way, say it a different way. So this is moving along the demand curve because in this two-dimensional representation of supply and demand, we only have 2 things to work with. We've got quantity, we got price. The price and demand. If the price falls, more quantity. Price rises, demand-wise, what's going to happen? Quantity demanded,
If the price rises.
quantity demanded goes down, right? If income goes up, what happens with demand? What does it mean goes up? What happens with demand? Demand or quantity demanded? Not quantity demanded. Demand shifts, right? It's the most annoying difference because economists are like, oh, demand falls, demand rises. But you have to be able to differentiate between a shift in demand versus a change in the quantity demanded. And here's what I mean by that. Simplify this little diagram here. Forget supply for a second. That's demand. From here to here, what's that called? The change in the quantity demanded, right? Because you're on the same demand curve. This demand curve is what's that expression ceteris paribus mean? All else held equal. What happens if this, whatever it is, this demander, somehow gets more income? What's going to happen?
Shift.
What kind of change?
Shift in demand.
Shift in the demand curve which way? Out, right? You're going to shift out. This is assuming that whatever this is a normal good. Okay? What's it called when it shifts in when you get more income? Inferior good, right? So when you get more income, your demand for expensive cars goes up, your demand for ramen goes down, right? Ramen is an inferior good, hopefully, unless you like whatever, you have this nostalgia for ramen. $6 bowl of ramen. Okay, so it's important to keep track of the difference between the quantity demanded and the demand curve itself. And I mean it's important in the sense that 99% of the people out there don't know the difference. When you're doing analysis, especially with this blogging type of stuff, keep track of the differences between a shift in demand and the quantity demanded. So, besides income, what's another shifter in demand?
Change in information.
In what sense?
Like when the whole low carb diet thing came out, the change in like the demand for carbohydrate goods
Fell.
fell.
Right. That's a change in tastes, in a sense, right? So, or that's what advertising is all about, shifting your taste. Suddenly there's something that you never thought you needed, but now you need it. And so, and need, that's the word that economists hate. You want it, right? Because you don't necessarily need anything. So, demand will shift based on a change in tastes. Tastes can change for a lot of different reasons. You might wake up in the morning and, you know, become a religious convert to not using that, whatever that product is, or the other way around. You might be persuaded by your friend, by advertising, by, you know, you go to the doctor and they say you have a tumor, don't use that thing anymore. Another popular example. What else can shift demand in and out? Substitutes, and what's the other one? Complements, right? Pork and Tabasco sauce, or barbecue sauce, all right? So, and there's, I don't know if there's another thing.
What about expectations of future prices?
Like a kind of buying now ahead of
Yeah.
for the future. That would be a question of short run versus long run demand, right? So if you think that prices are going to go up, then you're yeah, it makes all kinds of sense that you would buy more now. Essentially, what you have, if you're doing that, you have time zero versus time 1, and you're looking at, you have the same demand, and then you have a price, okay? And what you're going to do here is you're going to, rationally or not, or in a sense rationally, because you expect that to happen, if you think that this price is going to go up, then you're going to shift your demand out in order to store whatever that extra bit is. Does that make sense? I mean, that's exactly what, you know, I'm explaining what you said, which is a good example. Anything else? Any other questions on this thing? Yeah.
Why is that a shift of the whole demand curve instead of quantity demand?
Because the quantity demanded is only affected by the price right now. Okay, the future price is it's like the future price is something. It's not the price now. I guess that's the easiest way to say it, right? So this P is P0, but this demand. So if you say demand X is a function of income, other goods, all other goods. We're going to call it expectations, blah, 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 blah. Right? Tastes and preferences. This is the this is the math for preferences, or whatever, the symbol for preferences. It's kind of a squiggly, like, it's not like this. It's actually like that and like that. So that actually means preferences. Don't ask me. That's what we decided. Okay? But you'll see it somewhere else. I'll just say preferences a lot. But if you change your preferences, then you're going to change your demand, right? If you change the price, you're changing the quantity demanded, right? Okay, good. Good question. Any other things on this stuff? Okay, so supply side, and what underlies the demand curve? What drives demand in terms of the way that we want to think of how people are looking at the world? What determines what they demand? This other concept we use all the time in economics.
Elasticity?
Not elasticity. Utility, right? Because you have a utility function, you have a demand, right? Utility does not come from demand. Demand comes from utility, okay? Because utility, essentially, you have utility from X, right? And that will give you a demand function, right? I don't even know how to write this a different way. Is there a different way of writing the math on this, Diana? Do you remember?
It's the arg max.
Argmax. Oh, I'm not doing Argmax crap. Okay, so utility leads to demand, not the other way around. Okay? Moving right along. So I got to get through. We get to constrained optimization, which is so fun. So then, supply curve. What's the supply curve based on? Anyone? What was that? The marginal cost of producing the product, right? So the idea essentially is that because of diminishing returns to anything, diminishing returns to scale, diminishing returns to management talent, diminishing returns to machinery, any of those things, what it means is that as you increase the quantity of production, it actually costs more and more per unit of production. Now we'll get into the theory of the firm and the difference between fixed costs and variable costs. But right now, this is all the supply curve is based on marginal cost, right? The long run supply curve is all about marginal cost. There are no fixed costs in the long run because the long run is long, right? If your factory lasts 50 years, that's also, you're going to have a couple factories, a really long run, right? So a factory even is a marginal cost. It is a variable cost. So this is purely based on a marginal cost curve. What's going to shift the supply curve in and out?
Changing technology.
Technology. This is the most obvious one, right? If you get a new production process, technology will go out. Why would this supply curve shift in?
It decreases your marginal cost because you get new technology.
Right. No, you're explaining why it would shift out, right? Why would? Sorry.
That's why it doesn't shift in, because things don't become more
I'm
expensive.
asking an example. Why does it shift? Or when can it shift in? What's an example of that?
When the cost of production increases.
But why would the cost of production increase?
Resources become more scarce.
Right, potentially. So say that one of your inputs to your marginal cost is fuel, right? Oil price goes up, bang, everything goes up. I was reading an article about the Canadian tar. They don't call them tar sands. It's politically correct to call them oil sands, right? Because they're or happy sand. So happy sand used to the break-even point between whether or not you should go into production was at when oil was $80 a barrel, right? And that was because when that $4 gas was happening, there was this massive, the demand was still very high, and producers were all trying to put their fields in production. If they're all trying to put their fields into production, what happens with the demand for inputs? Such as, what's an input to oil production? What? Derricks, oil derricks, machinery, what's another input? Labor, oil, machinery, labor, anything else?
Barrels.
Barrels, steel barrels. Can't put it in the barrels, not going anywhere. Tankers.
For oil sands, we need a lot of water too.
Water, okay, so oil sands in particular, a lot of water. So what happened when there was this massive increase in demand is that everybody and their brother was working already in Alberta, for example, and there was still more demand, so the costs were rising very quickly. The unemployment was about 0%, probably 0.1%. So that meant that the price of a laborer went from, a truck driver went from $18 to $25 an hour, right? Same thing happened in Australia with the minerals, with the demand from China for coal and steel, or iron. So because of that massive demand, the prices, because demand went from here to, I got too many curves now. So because demand went from here to here, you had this kind of a price difference, right? So the price of oil went higher. Oil, a substitute for oil is what? From Alberta. I just said it.
Coal.
Huh? Tar sands, right? Sorry, oil sands, happy sands. Tar sands. All right. So when the demand shifted out for oil, then the price went up, and the demand for tar sands as a substitute good went up, right? And that meant that it was economic to. So tar sands are, they were not. It's not economic to oh, it's like too many different little graphs here. That should be a good homework question, actually. So the demand for tar sands went up, and it actually meant that it was more profitable to do it. And that meant that they were pulling in more and more and more of these truck drivers at higher and higher wages until the demand for labor actually went up, blah, 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 blah. All these markets, this is this general equilibrium kind of hand-waving. But basically, when oil was really expensive, there was so much demand for labor that the break-even for going between oil and tar sands was $80 a barrel. Now that the world has had a little bit of an economic problem, the cost of all these inputs has fallen. Labor, rubber, trucks, not even water, natural gas is another input. It's fallen, so the break-even is now $60. So now these fields that were not economic in the middle of at the end of the boom are now economic again, right? So that is the cross-price elasticity between oil and tar. A lot of hand-waving there. I can definitely see a homework problem from that one. This is going to be great. Okay, so supply will shift in and out based on technology and all the other markets. It's the same thing as a cross-price elasticity. I'm going to leave off that thing here. Okay. Now, here's a little footnote just for your edification. I've actually worked on this problem, this question a lot, and it turns out to be a little bit confusing to students. So demand curve what's the difference besides what I just wrote up there? Which one do we use all the time? The one on the left or the right? The left. But it's called an inverse demand curve. Inverse because it's inverted from this. Because often the quantity demanded is a function of price. You go on the market and you say, oh, I want an iPhone, or I want a quart of milk, or how many quarts of milk do I want? I look at the price, right? You don't go in the market and say, I want 3 quarts of milk, and they say, oh, the price is going to change based on that. Okay? So as a historical accident, we use the inverse demand curve, but really what's going on with demand is a function of price. Okay? And I want to point this out because a lot of people get confused because they go out in the world and they think, I demand stuff according to what the price is. But we have, in economics, we have quantity down here. This is usually the independent variable. This is the dependent variable. But it's inverted. That's why we have it here. So the quantity demanded is a function of price. We invert it throughout economics for the sake of convenience because we can compare. This is easier to use in terms of comparisons and graphical stuff. But I want you to know that that this is where it's coming from. So just so you know, I guess is the way to say it. I don't know, probably just so you don't care, right? But it'll be significant if you're doing math and you're trying to aggregate demand from 1 or 2 or 3 people. Because basically what we do is we say the quantity of Mr. 1 is equal to, let's say, the quantity demanded is going to be a function of P, and the quantity of Mr. 2 is a function of P also, a different function, G, right? When you want to add those two and get aggregate demand, let's do this by 1 plus Q2, then you're going to have, that'll be accurate, right? But then you're going to have to flip it back over again to make P as a function of Q if you want to graph it. You're like, oh my god. So I'm saying it because 90% of students get tripped up on this addition because they forget to do the inversion. The inversion is tricky. Okay? So this is how the world works, and this is how economists present the world, which is by inverting the world, which is, again, not a shocker. Any questions on that or anything else? Demand, supply? Okay.
Can you go to the Q1?
Q1 is just the demand from individual one. This should be Q1. Right? So if you want to aggregate the demand from individuals, here's the way to see it. If you look at the demand here at a price, right, and then you have someone else's demand at the same price, then it's fairly easy to add these up. And this is going to be Q. Let me put this here. This is Q here. Okay? It's easy, you just add it up. If you're doing demand here, we're going to add it the other way around. And this is Q. So you're adding this way. And that ends up being kind of counterintuitive when you're adding that way. That's the reason I'm pointing this out.
So then you add up enough, the top of the graphs are the same, and it's just like flattened out.
No, this number is not going to be the same as this number.
But,
Or the shape there will not be the same
but
either.
in this graph, if you keep adding quantities, does the top of the graph stay the same point in this equation?
This one here?
Just flatten out a little bit.
If I keep adding quantity this way?
Yeah, so quantity moves past the current demand.
Mhm.
Does that mean
If you just keep adding quantity, the demand curve is going to be going like, the demand curve is going to be shifting out.
it's going to be shifting?
Yeah, and in fact, it's the same thing, but you're adding it a different way, right? This actually matters for things like public goods, which we'll get to later. And I'm just bringing it up because you might be saying, why do I care about this? But it's important because look at that mess on the board. It's important because we think of the world as consumers, right? Or even as producers. If you have a company and the going rate of selling cars or iPhones or whatever, haircuts, is $14, you're like, oh, I'm going to work this many hours, right, as a producer. You don't sit there and say, I'm going to work 12 hours and that's going to determine the price. It doesn't happen that way, okay? The only time it really happens is in the market. The market, price and quantity are determined jointly, but that's the macro. On the micro level, quantity is a function of price, whether or not you're a consumer or a producer. But then we invert it when we present it on the scale, right? Which is counterintuitive to people that have the math to understand just basic graphing. All right, so let's go briefly over elasticity. We'll be coming back to supply and demand endlessly. But this is some overview comments as usual. What does elasticity mean? Anyone? Okay, that's how sensitive you are to changes. I'm going to call it changes. The general concept of elasticity, right? Price elasticity is how sensitive you are to price changes, right? So, the elasticity of demand for, let's keep our favorite example 4, is that greater than or less than 0? Sorry? The elasticity of demand for pork is greater than 0? Who agrees with that? Who disagrees with that? Who has no idea? Who's too lazy to raise their hand? Come on, you guys. God, it's like 11 o'clock. It's like coffee time? Okay. Own price elasticity is less than 0. Why is that? Well, there's this thing called the demand curve, remember? Right? What is it? So let's ask, what does elasticity mean? Let's back up a second. Besides this idea of how responsive you are. How responsive you are is the measure, is the quantity of elasticity you get, right? The idea of elasticity is much more simple. It's the change in quantity from a change in price. Okay? Quite simple. Calculus, whatever, continuous function. And it's actually, technically, it's at a certain point. So another way of writing that, here's the simplest version of writing it, sorry. It's the percent change in quantity over percent change in price. Okay? That's your basic price elasticity. What would income elasticity be? Over income, right? Percent change in income, right? It's the same idea. It's just essentially it's a responsiveness thing. And if something is elastic, is it more or less responsive than it's elastic? Inelastic. Sorry, I'm falling asleep. If the item, if the price elasticity is elastic, is that more or less responsive to the price elasticity that is inelastic? More, right? Just boing. Just think of a rubber band. It's just a very simple word. We throw it around a lot, but keep it straight. Okay. So here's something that's interesting. Here's our demand curve. Where is elasticity? Where is A, B, and C? Which is more elastic? C. Who's everybody's okay? Everybody, let's see. How am I going to do this? Gotta put up your hand. Okay. A, B, and C. Who thinks A is more elastic? Nobody. Who thinks B is more elastic? Nobody. Who's here in this class? Everybody thinks C is more elastic? Is that right? Everybody? You're all wrong. Which is more elastic? A is more elastic. Why is that? It's this little trick here.
Is that a Q in the bottom corner? I'm just confused about what's going on the board.
Okay. The messy handwriting strikes back.
Well, when you
That's
write,
all right.
okay,
That is a Q.
so that's as a demand curve. So you're saying A is the least amount demanded
That's right.
on that demand curve.
Mhm.
Okay, so now I get it.
Now you get it?
Yes.
Awesome. Okay.
It looked kind of like a G. I thought I was lost.
No, you're not lost. You're still in Q land. All right. Sorry. That's the bad handwriting strikes back. A is the most elastic. Now think of it for a second. Think about your demand for water. Okay? You have this much water. Or whatever. Do you want more water, or do you care very much about having more water? You've got a swimming pool full of water. But then I say, you know what? I'm going to cut back your water supply to this. Right? Are you really excited about getting more water at A, or are you really excited about getting more water at C? A, right? That's essentially the intuitive argument. The mathematical dq dp, P over Q, the math, the change in Q, change in P is the same because this is linear. It's the same the whole way along there, right? But this is the key part here. As Q goes to 0, what happens to this whole equation? As Q goes to 0, this is the same. What happens to this equation? Goes to infinity, right? So as Q goes to 0, elasticity goes to infinity. At point B, there will be a point B on every linear demand curve. Elasticity is 1. It's called unit elastic. Just because P over Q is 1 or something like that. Okay? So it should match. I want this to match your intuition. As you have less of something, your responsiveness to price is going to increase. Okay? And as you have more of it, your responsiveness is going to decrease. Responsiveness is different from quantity demanded. But those things are both happening at the same time. Okay? What's the elasticity on this curve? Which I'm going to call a constant elasticity curve. Is it changing, like over there, or is it constant?
Since you called
It's constant elasticity curve, right? I mean, this is like a trick question. What? Because this is changing now, right? This is a slope. The reason that we use calculus all the time is because it's a slope, okay? So the change in Q, change in P, it's very steep over here. You can figure this out on your own. And over here, it's very shallow. Okay? Now take that into consideration. If the elasticity is constant on this whole curve here, okay, and over there it used to be inelastic, that curvature is adding, in a sense, this is an intuitive thing. I'm just trying to say it in words. You're adding an elasticity, and here's what I want to say with this so-called intuition. Is if you have Q and P, you have this demand curve or this demand curve. Which one is more elastic? D2 is more elastic because essentially, if you take a 1 unit price change, the change in quantity is much greater. It's more elastic. There's a bigger response. That's essentially it. Okay. If this was the same person, and it was the only difference between these two demand curves was short run versus long run, which one is long run? D2 is the long run, right? In the long run, things are more elastic, right? You have more time to respond. When I said that factories are a marginal cost in the long run, this is the exact same thing, right? In the long run, things are more elastic. Think about it. It's a hot day, and you don't have any water. You're probably willing to pay a lot of money for some water. Okay, that's a short-run phenomenon. But over a week or a month, you're not willing to pay as much for water, assuming you're still alive, right? Because you have multiple points of drinking water, right? In the long run, your demand for things is more elastic because you have more choices, more time to respond, more ability to substitute, stuff like that. That's the intuition behind here. So that's what we mean by the elasticity. In the long run, everything is more elastic. Essentially, it's a human assumption that economists use in their work all the time. In the long run, so think of it, go back to that oil example for a second. In the short run, the price of oil goes to $140 a barrel. How easy is it to bring more oil into production in a day? It's hard. In a month, it's easier. In a year, it's much easier, right? Holding that, not worrying about demand. So if you have more time to adjust to things, then that's essentially meaning more elastic. So the supply is more elastic over time. Demand is more elastic over time. And in fact, everything just flattens out over time. So you'll have supply, this is one supply, and that's another supply. Which one is more elastic? One or two? One, good. And that's why the long-run supply curve is sometimes drawn like that, just flat, right? Perfect adjustability, and it goes straight to price. This happens all the time, very weird. It's greater. Sorry, no, it's not greater. When you get more income, do you eat more ramen or less ramen? Less, let's hope, right? Forget the nostalgia stuff. So, it's less than 0 if you have inferior good. That's the entire definition of an inferior good. You can, you're a college graduate now. You know the difference between an inferior good and what's the opposite? Normal good, right? And there's this other thing that theoretically exists, a given good. Forget it. Who cares about that? Okay. So that's elasticity. For now. Caveats. Oh, yes. Now here's an interesting thing. Remember I said the difference between theory and reality? When we measure elasticity, we use this equation. This equation is it's used for calculating what's called point elasticity. Elasticity at this point here. And what if I measure that and I find whatever, that it's minus 0.5. Okay? Forget that this is linear for a second. you're an economic analyst and someone pays you $10,000 to estimate the price elasticity for pork or whatever. What happens? That's your price observation here. What happens if I say, well, what's elasticity for pork here? Can you say, what is it going to be 0.5? Is it going to be greater than 0.5 or less than 0.5? Greater, in theory, it's going to be greater because of what we're talking about. But you never know. It could be, it could be going this, and it could be like that, or it could be like that, or it could whatever, right? So the problem is that when you estimate point elasticity, it's only good in what region? A big region or a small region? Small region, because remember that often calculus, which is what this is a point estimate. It's like infinitely small change, right? An infinitely small change in price and an infinitely small change in quantity. The reason I bring this up is because elasticities get abused a lot. Oh, the elasticity is 0.5. Fine, I can use that all the time. No, you can't, right? Because some big paradigm shift might happen. So we don't really know what the demand curve. We know vaguely that it goes downward, but we don't really know what it looks like. And that matters when we go back to that empirics. I was cautioning you guys on that on Tuesday. So that's annoying if you're trying to actually estimate something important. All right, so we have a few minutes to go over constrained optimization. Any questions on this? No? We'll be back. We're doing consumer theory in the next, or consumers in the next lecture. So let's do this as a just a quick example of a constrained optimization. I get utility from two goods. But it's subject to a budget constraint. The price of X plus price of Y is less than or equal to my income, right? If you don't have this, how much do you consume of X and Y? As much as you want, right? Assuming non-satiation, infinite amounts, right? Because your utility only comes from this thing here. So the constraint is this. You only have so much money, right? You could say you only have the width of your belly. This is, Adam Smith said that. He said, our demand for food is limited by the width of our belly. This is our width of our wallet. So we have to find out how much. I actually put some numbers on here. Let's say the price of X equals 2 and the price of Y equals 3. And let's say that our income is equal to 10. Now the question on your homework would say, how much of X and Y are you going to consume? It's not necessarily obvious how much you're going to consume. Oh, what is obvious? Are you going to consume more of X or more of Y? More of X. Because relatively speaking, you get the same utility from X, but the price of X is lower. Okay? So here's how we're going to figure this out. We're going to set up what's called a Lagrangian. Write this down. Yeah.
Are we assuming X and Y gives the same marginal utility?
Yes, we do. Because it's the same superscript, right? If I said something vague, then if I just said u of X, Y equals whatever, the function of X and Y, then who knows, right? But I'm defining it as a root. Okay? So we do our calculus. We take the derivative with respect to X. We find that 1/2 X to the minus 1/2 minus 2 lambda is equal to 0. This is a first order condition from calculus. If you haven't heard that before, you're going to hear it a lot. First order conditions. Okay? We take the derivative with respect to X, and we get this. And then if you don't like derivatives, now's the time to relearn it. Okay? Put this in the front, you take away 1, and that's how you get it. Take the derivative with respect. Can you guys see in the back? This could be bad, actually. Well, whatever. Hopefully I won't go down too low. Derivative with respect to y equals 1/2 y to the minus 1/2 minus 3 lambda equals 0. So you've got two equations and three unknowns, which sucks. So we're going to rewrite this up here so you can see it. It's a little trick. X to the 1/2. And I'm going to say, see it says minus 2 lambda. I'm going to put that on the other side. Everybody follow that? Negative 1/2. 1/2 y to the minus 1/2 equals 3 lambda. You divide this side by you divide this equation by that equation. You can cancel out the lambdas. That's convenient. You cancel out the halves, and you get x over y minus 1/2 equals 2/3.
Where does lambda come from? What is lambda?
Lambda is, it's just used to make things easier, but it actually represents what's called the shadow price, or the shadow value. And in this particular example, right, this lambda. So essentially what lambda tells you is how valuable is more income. How much more utility do you get from more income, right? We're not going to calculate lambda, but it's giving you an idea of that. Okay? So we have this equation now. Let's just take each of them to the minus 2 power. So that cleans up x and y. Equals 9/4. Minus 2 power, invert it and square it. Okay? And then we get x equals 9/4 y. 9/4 y. Does that mean you consume more x than y or less x than y? More. 9/4, greater than 1. Okay? That's what you guys said at the start, because why? The price of x is greater or less than the price of y? Less, right? Good. We're doing good in terms of reality. Now what we can do is we can say x is equal to 9/4 y, and we can substitute it into the last equation here, which is lambda Lagrangian with respect to lambda, and that gets us this. Just spits it out. 2x plus 3y equals 10. Okay, minus 10 equals 0. Equals 10. So if we know that 2x plus 3y is equal to 10, then we substitute in this, and we get 2 times 9/4 y plus 3y equals 10. And then we get 9/2 plus 6/2 y equals 10. 15/2y equals 10. Convert that 20/15. And we have y is equal to 4/3. Trust me on that for a second. Y equals 4/3. X is 9/4 y. X equals 3. Do we consume more x or more y? More x, like we know we should be doing. That's the solution. That's 100% credit on your homework. I mean, you have to show your work, right? But that's what you want to do. Okay? This is a technique of constrained optimization. It makes the algebra, or the calculus, whatever you want to, it's mostly algebra. It makes the algebra work out more easily. And it looks like a wreck, but it's a very step-by-step cookbook type of thing. Okay? We'll be doing it on homework. We'll be doing it in discussions next week. Have a great weekend.